Hello and welcome to our Manufacturing Today webinar on flexible automation. My name's Sarah Underwood and I'll moderate the webinar for Finelight Media, the publisher of Manufacturing Today. I'll ask our speakers to introduce themselves in a moment, but first just a snapshot of some on-demand Manufacturing Today webinars you may be interested in watching. They just came up in that little video. Engineering the Future with Human and AI-driven analytics for faster, smarter semiconductor manufacture. And sorry, I've read that one. And the Next Gen Factory, Mastering IT and OT Convergence for an Intelligent, Resilient Future with AI Data and 5G. You'll find those on the Manufacturing Today website. Also, a little practical information for our audience. So we'll be running 3 poll questions during the webinar, and we'll be using Slido so that you can take part in the polls. You can also ask questions to the speakers using Slido, so just put those in whenever you'd like to, and we will answer them when we take a break to answer your questions. And do take part in the polls. It's very interesting to know where you are in terms of your progression towards automation, robotics, and so on. We'll also put the Slido web browser link in the chat bar on your right, and if you can use the QR code or go to Slido and use the code #MTWebinars. If that's something that you can't do or don't want to do, we'll just put everything up in the chat column anywhere. If you want to ask some questions there, that's absolutely fine, and they'll be transferred to me here on Slido. So thank you very much indeed for that. And let me come to our speakers and ask them to introduce themselves. First, Jeff.
Hello, my name is Jeff Rogers. I'm the Vice President of Business Development for Benchmark Electronics. Been with Benchmark just shy of 2 years, but have been in the electronic manufacturing space for about 13 years total. Prior to this, my background is in industrial automation and controls as a motion control specialist for a regional high-tech automation provider based in Dallas, Texas. Pleasure to be with you this morning.
Excellent. Thank you very much indeed. And Justin, over to you.
Hi, Sarah. So my name is Justin Blair. I've been with the Benchmark going on almost 4 years now. I started in manufacturing about 15 years ago as a manufacturing engineer. Worked my way through different businesses in different industries, gained a lot of hands-on experience programming robots through automation systems, designing, developing and implementing systems. And now for Benchmark, I work for the Global Operations Excellence team. We specialize in identifying projects and opportunities for different sites and work with customers to try to achieve efficiency and any sort of goals that we're looking for from an overall product structure. So really looking forward to the conversation today, Sarah.
Great. Thank you very much indeed. And Carol, over to you.
Sarah, thank you. Yeah, I'm Carl Kruger. I'm an associate professor in automation systems at the Institute for Manufacturing at Cambridge University in the UK. In my teaching, I teach our manufacturing engineers production and machine control and automation. And in my research, I've done a lot of work on intelligent manufacturing systems, more recently on digital twin systems and human system integration.
Okay, thank you very much indeed. So plenty of expertise in the room for the webinar today. Let's get started with a poll question, if we may. It asks, to what extent has your organization automated complex product manufacturing? So while you answer that question, let me come first to Carl to talk about complex product manufacturers and how much progress they've made towards automation.
Yeah, thanks, Sarah. It's a difficult question because it's all depending on what our viewers are going to answer in this poll. So maybe my answer is way off. But I think it's automation in terms of complex product manufacturing is interesting, because I think the complexity in some cases is a barrier to automation, and in other cases it is essentially a driver for automation. I think it's really dependent on the product, but also the context of the manufacturer. I would say that in general, I think we've seen substantial automation. driven by some emerging requirements and drivers which we'll get into in this webinar, but also it's been driven by opportunities and advancements in some critical technology, which has made it easier than ever to implement automation. So I would say in general, from my perspective, there's been some substantial progress in automation.
Okay, that's great. Justin, when you're out and about visiting customers and places, or how are you seeing progress here?
Yeah, I think Carol touched on it perfectly. It really depends on the situation at the site. Since we're a global organization, every site is kind of at its different stage in the progress throughout automation development. I think pinpointing certain skill sets and challenges that each site might face really helps us open windows on how we can make it a little bit more easier. As Carl was indicating, it can be very challenging to identify those opportunities. So some of the biggest things that I've seen is, instead of silo workstations where you have single operations and single robotic cells that perform, a very static task that can't really be modified over time, we've seen the transition to communication between multiple workstations that can perform multiple tasks. And I think that evolution of how data is transferred between those workstations is really where we're seeing the biggest payoff on how the data is captured, how it's transferred between those workstations, and then how are we storing it. So we started off, for me, 15, 20 years ago, when I was, programming robots, it was CNC G code. And now in this day and age, we can program robots through voice and other sort of commands. So that training aspect of, bringing people on in the organization and at sites to not have the limitation or barrier of programming or coding experience, I think that's given us probably the easiest ability and access to kind of deploy these projects. So yeah, super. I think we've seen a lot of progress in different areas, but there's still a lot to make depending on funding and customer requests.
Okay, I think we'll come back to that in a little while. And Jeff, how do you see the progress being made when you're talking to clients?
Yeah, I think further to the comments from Justin and Carol, it's really, we're seeing a shift towards a lot more software-defined robotic cells and systems that enable a lot better flexibility. The other thing that we're seeing is virtualization is coming a long way. It's essentially, computer-aided design, but for automation solutions, right? And so that allows, kind of a sandbox rather than the trial and error approach, right? To making sure that you're deploying automation solutions as efficiently as possible. Other comment I think I would make is we've seen a lot shift in automation technologies towards electrification solutions, and a bit more away from more analog solutions like pneumatic or hydraulic, as far as power transmission essentially. And that could enable a lot more control, precision, repeatability, but also flexibility and communication, as Justin mentioned, between automation cells.
Okay, thank you very much indeed. Could we see those poll results, please? And Carl, perhaps you'd like to comment on these. As you say, it's all a bit dispersed, but okay, what does that look like to you?
Yeah, I think, and Justin did mention this, that there's definitely there's a lot of room for progress. And I mean, I'm not surprised that there's quite the majority of our viewers indicate that there has been some automation, and I think we'll get to maybe the strategic approach of selective automation. So identifying the key parts of processes that are give the best return on investment in terms of automation, and that's why I think we see implementation to a limited extent. But of course, there's a lot more to do, and a lot more that could be done in the future.
Of course, thank you for that. And if I may come back to you, Justin, to outline the requirements and drivers and technology enablers of automation in this sector.
Yeah, absolutely. I think one of the biggest things that's not talked about enough is the design for automation and assembly. Up front, I see a lot of customers that have designs that are already in production that have been sold to customers. They have semi-automated solutions that were either put together internally or had 2 or 3 suppliers work together. So I think designing the products so that they can be automated and simplified for handling purposes up front really is probably one of the most deterministic factors on if it's going to be successful or not. The customers have to be willing to take suggestions from whether it's our company or anybody else in manufacturing, because designing for automation is definitely different than designing for manual assembly, because the way that the parts interact with the processes and the equipment might not always be the same. So if a workspace, it needs to be enlarged because the robot is larger and needs to move around, then we obviously need to adjust maybe some of the design principles of not only the product, but also the system. I think traceability infrastructure is probably our bread and butter internally. We have homemade PFS systems, which basically validates any of the product and process information that's tied in to our internal benchmark system. So we're not only tying data together that can be communicated between equipment in our building, but also between the coding and the software of each as well. So all the data, no matter what system it comes from, consolidating that so that operators and team members can pull that information. I think we do a very good job creating the traceability infrastructure. And then I think one of the last principles that isn't really talked about at all is basically creating a digital thread. So the digital thread, I think from a requirement standpoint, can be adjusted from what the customer actually wants. We don't always need to constrain our system and collect data at every single point in the process, because it can be very constraining on the system as well as our data infrastructure. So those few things on requirements, I think we've tried to focus on, just so that we're kind of pointing towards the drivers, which for me, cost, I think, is the biggest thing. We need to understand what the customer or what our sites are willing to spend the money on, and then also what the results are going to be. We don't want to over design a system where we're putting even sometimes millions of dollars into it, when we could simplify it and maybe get a little lower output, but get the same quality and also the same productivity that's being required by the customer. So we can give you, flashy wheels, just like you would buy a car that you might not need to drive as fast as it can. The system's the same way. And then I think scalability, obviously for us, being able to scale design concepts instead of recreating the wheel over time. And it not only allows us to reduce the costs and the design and testing processes, but it standardizes our approaches when we're doing the testing on the back end. I think the scalable aspect is we don't always see production runs that start at a certain number and then end at a certain number over time. We generally will see ramp up. So that scalability is a huge consideration. And then the last part is the enablers. I think AI and machine learning, I want to highlight the most, because those are the ones that are going to give us the biggest windows for expansion at each site. Also from a scalability in the aspect of what the AI can do for us. So deploying coding and software much quicker, analyzing data and metrics at each workstation for defect analysis. And then also the last portion of it is the communication between architecture, between everything. I think that enabler, if we code everything right, if we design spec the PLC control systems correctly, those are all done up front. And I think at the back end, if we have the design software, the communication architecture, what it should be, and the data collection methodologies, those enablers of putting the system together right and designing it for the customer, I think ultimately gives us the best results.
Okay, thank you. God, that was a lot of information. What would you like to add there? You sort of touched on the kind of drivers and where you might be in this kind of space.
I agree with everything that Justin mentioned there. I think in terms of some drivers and requirements, I think the increase in international competition basically forces manufacturers to differentiate themselves in terms of their production quality, the lead times, and then of course the other important thing is customization, which is in terms of our topic of flexibility, is essentially the key enabler for manufacturers to differentiate themselves and to serve their markets in that way. In terms of technology, to add to what Justin mentioned in terms of the emerging opportunities for machine learning and AI in general, I think there's been some really important technological enablers. We can start sort of at a low level, so essentially the capability and usability of industrial controllers and robots. If we consider how we had 10 years ago, even maybe 5 years ago, standalone machine vision systems and how integrated this has become into industrial PLCs or industrial PCs. Robots, the ease of robot programming, with the emergence of cobots, and whether that's the right term for what these robots really are is debatable, but in terms of the ease of programming and the flexibility that they offer in terms of use cases and applications, been really important. And then I think in terms of AI and machine learning, it's really leveraging the improvements in connectivity. So we're thinking of industrial IoT, technologies like MQTT and how much that has grown basically in other sectors, but in manufacturing as well. Something like OPC UA performing as sort of really integration layer there. And then this has all led to the convergence of information technology and operational technology. And that's where, this abundance of data, the intelligence that we can embed through machine learning and AI really gets, we can locate that much closer to the shop floor, which I think is where we'll probably in the near future see the biggest benefits in those applications.
Okay, fine. Staying with you, Carl, it's a sort of very similar but slightly different question. It asks what emerging approaches to automation are available for manufacturers of limited volume complex products. So, how they're approaching these things. We've mentioned ML, we've mentioned all sorts of things. Where do you see the key approaches here?
Yeah, so I thought this was a really interesting question because I've been, doing research in automation for some time, and I've sort of looked at the history and progression of these systems. So there are some really interesting things that I think manufacturers should be aware of when it comes to how they approach automation. I think a sort of a strategic view, and I did mention this, is the idea of selective automation. You do not have to commit to automation at a large scale. I think it's great to have strategies to ramp up in terms of automation, but very often with selective automation, the right part of your process, you can really reap the benefits from that. In terms of some automation or approaches to automation that's really been well studied, especially in academia, and this obviously preceded industry adoption to some extent, are flexible manufacturing systems, which is really the focus of our talk here, where we basically have automation systems that have the capacity for change and for handling variations or variable processes and production, and slightly more intensified version of that is what we call reconfigurable automation, and that is where essentially you design your automation system in a way that you can more easily really exchange resources, add or remove to make more drastic changes to the products that you'll be producing. And interesting for people out there who would be interesting in a more philosophical view of this, there's a concept called holonic manufacturing systems that I've done quite a bit of work in, which is a sort of architectural approach of how one can go about, especially on a control level, enable flexible and reconfigurable manufacturing. So those are just a few ideas for people to look at, maybe read up on, for some guidance and inspiration in terms of how they, as a company, should approach automation.
Okay, thank you. Justin, what would you like to add there?
Yeah, I think those are awesome points, Carl. The biggest thing for me right now is collaborative robots and how we redeploy those over time, because I don't always want a collaborative robot to do one thing like auto screwing. I might want it to do a gripper and placement action as well as an automated inspection. I think generally speaking, when you integrate systems like Carl was suggesting, where you can have multiple processes being parallel processed at the same time in the same system, it really gives you that sort of flexibility on what you can do with a single cell system without spending a ton of money on multiple cells. That communication structure, obviously the approach that robots communicate with each other, and then also are modifiable, self-modifiable over time. So instead of an operator going to the robot and taking the tool head off, the robot can now do that by itself And based on serial code recognition in our system, the tooling can auto adjust itself. So if the size of the product is very similar, which we generally push towards, like if we're running a lot of SKUs, we like to design the system so that it can accommodate a few different configurations in the same product line. So instead of designing systems for a single cell solution that is only able to perform a single process, now we're giving the window into this. The collaborative robot is A, selecting the tooling based on the camera inspections, and then B, it's modifying its programmable path points without an operator having to go into the coding itself. So the collaborative robot environment is probably our biggest opportunity to utilize multi-processing robotic cells. The digital twin aspect of taking the layout of a floor or a design system and then proposing what those process or cycle times might look like in advance, I think that gives customers and also our engineering teams the ability to either redesign processes up front based on machine cycle time estimates. And then also it gives designers, I think, the creativity to really see what the floor might look like with the equipment on the layout that's proposed. The modular automation cell design I touched on a little bit earlier, and that was how do we really take a single design and scale that up. So if it's one robot with one pick and place machine and one part feeder, if the volume goes up 10%, can I add just one piece of equipment or two pieces of equipment that can just basically interconnect with conveyors, but also perform the same exact processes that the equipment had been performing for months prior. So I think standardizing the systems for a modular connection point where you can redeploy a 4x4 meter cell and move it across the building 6 months after you deployed it and not really have to change anything except infrastructure. That to me is where you're really getting your bang for the buck. I think from an additive manufacturing standpoint, your tooling can be one of the most costly extras when it comes to fixing designs after the fact and then also testing. So the 3D modeling and any type of additive manufacturing, I always suggest making the tools up front on a cheaper cost material and then going from there. So the additive manufacturing has given us flexibility. The vision guided robotics, I think, is our bread and butter this year, which you'll see a lot of things coming out of Benchmark in FY26, where the vision guided robotics is kind of dictated by AI and machine learning. So I think those are the biggest things. And then the traceability integration. Obviously, we want our customers to be happy on what the data is we're collecting.
Okay, thank you. Okay, so let's move on a little bit and let's run a second audience poll here, and it asks, what are the benefits does your organization gain or expect to gain from flexible automation? And while you answer that one, please feel free to tick as many of the little boxy things as you like, which are appropriate to your organization. Let me come back to Justin, if I may. Justin, with a focus on flexible automation, in which markets is benchmarking seeing the biggest demand for automation, manufacturing, and robotics deployment, and what benefits are these sectors gaining?
Absolutely. Yeah, I think medical devices, Jeff can definitely speak on this later on in some of the conversations, but I think medical devices has been one of our biggest increases on automation that they've either had in different regions of the world, and now they're looking at sourcing it in different locations where Benchmark maybe didn't produce in the past. So medical devices, precision molding manufacturers that require assembly and one-time usage and then throw it away type of deal. And then one of the other ones is power electronics. So servers, GPUs, any sort of electronic industrial requirements for mass data migration centers. I think we're seeing a lot of requests on certain aspects of the data centers. So how does the data get stored? What hardware is used to store the data? We actually do a lot of requests for making systems specific to data centers. So I think what it ties into, outside of aerospace and ITAR, which obviously has different requirements than other industries, I think ITAR, aerospace, we have a consistent flow with them because we are the United States government and ITAR is specific to our region. But I will say this, that I think with the automation development that we've seen the last year or so, we've had an uptick in certain previous or current customers that didn't look at automation through us and now are. So I think Those three industries are probably our heaviest hitters. Some of the biggest wins that we can get, or I guess benefits that are delivered for them, are obviously the changeover times and the tooling, kind of like what Carl and I were just touching on. If we have multiple systems that perform different tasks, we want it to be as quick as possible and also as effective for our team members. So changeover, increasing capabilities on what products can run in certain lines. Obviously, our quality is our biggest driven metric outside of safety. So the quality of our systems, we shoot for anywhere between 20 and 30% increases in certain processes, all the way up to 70% in other processes such as screw feeding. So I think the output and the productivity, you're definitely going to see the wins there. Scalability, improved quality, and traceability, they all kind of tie together, because the traceability, you want to be able to scale that up and you want to be able to monitor that over time. So I think those critical factors of how that is benefiting automation and selection for customers, it's really driven by the product, the location, and then also some of the volumes.
Okay, Jeff, what would you add there? Where do you see the potential for this type of automation?
I think where we're seeing it most prevalent currently, to Justin's point, one market sector is certainly medical devices, especially with the emergence of consumable electronics, which leads to, I guess, what I would refer to as ultra high volume manufacturing. Tens, hundreds of millions of units that are disposable on an annual basis, almost necessitates the need for automation, if nothing else, just to prevent outrageous amounts of floor space consumption, and also variations in product quality when you're working with that high of volumes. So that's one. I think another one is, and this kind of goes across various market sectors and is more geographically related, which is, there's been a much greater emphasis on supply chain resiliency over kind of the past 5 years. And, be it geopolitics, be it, worldwide pandemics, you name it, has really driven the need for kind of a rethink in terms of supply chain architecture strategy, and the need for, you could call it nearshoring, but excuse me, it's really localization, manufacturing localization, closer to the endpoints of consumption for our customers. And so sometimes that may mean, localization into a high labor cost region, right? Because that's where the point of consumption is. And so then the economics behind manufacturing and the costs that are involved can also necessitate the need for automated solutions, just kind of take advantage of reduced labor costs. Again, it's also repeatability, reliability in terms of quality, and that kind of goes across all sectors. So, as far as geopolitically, there's obviously been a much greater emphasis in North America for interest in U.S.-based manufacturing, and that's traditionally a fairly high-cost manufacturing region relative to many others, even in North America, if not throughout the world, where there's been a greater emphasis on at least automation of low-skilled or non-skilled tasks to try and alleviate some of those higher labor costs.
Okay, thank you very much indeed. Could we see the poll results, please? And Justin, would you like to have a quick look and tell us if you think what the audience is telling us is sort of along the lines we might expect in terms of the benefits they're gaining or expect to gain? We've spoken a lot about speed and efficiency, so what do you think of that?
Yeah, I think that's totally on par. Actually, before we even started, I had answered pretty much all of them. I think all of them are valid answers because they all tie to the benefits. For me, speed and efficiency, the speed of deployment goes hand in hand with the speed of design as well. So I think upfront designing and deployment is just as critical as the speed and efficiency while the systems are running. So we try to focus on both, but yeah, I think that's spot on.
Okay, thank you very much indeed. And Jeff, coming back to you, how do robots combined with AI adapt to changes in manufacturing to support variations in demand and product types? That's quite complex, but I'm sure you know the answer.
Yeah, I guess I'd refer to it as AI-enabled robotics. Really does allow for greater flexibility and accommodating, if nothing else, light variations in, production processes relative to, let's say, product variants. I can think of many different examples. One would be, for example, automated guided vehicles that are used in production processes are becoming more adept at obstacle avoidance, as well as route optimization. And that can often be some low-hanging fruit, so to speak, in terms of that low-skilled or non-skilled labor, literally just moving materials between stations, or perhaps from a storage location like a warehouse, where that's ripe for an automated solution. And AI-enabled robotics make those systems much more flexible, so that they're able to adapt real time to changes in the environment. The other one I would mention is packaging on demand has become a really hot interest in the manufacturing space, where you're essentially optimizing packaging dimensions on the fly while a product is traveling perhaps on a conveyor to meet that packaging solution that has is still just raw corrugation, right? Hasn't been cut to size, but happens in parallel during that travel path. So it's really leading to environmental impact, optimization and reduction. And a lot of that is AI and machine learning driven to be able to adapt to the changes in dimensions of products that need packaging solutions.
Okay, thank you. Carl, what do you see there in terms of combining AI and robots? What can you achieve?
Yeah, I think there's some really interesting opportunities, and I think when we think about integration of AI with robots, so if we consider industrial robots or AGVs, I think there's some interesting opportunities to be unlocked in terms of how we use simulation environments to support this. So if we think about the role of digital twins as these digital environments where we can implement models, develop models in that sense. If we think about how we could use simulation to accelerate the adaptation of robots to changes through either reinforcement learning or transfer learning. So reinforcement learning, essentially trying different things and essentially continue to do those that work better. Transfer learning, essentially working on a model that you've trained on a specific task and transferring that and giving you a bit of a head start when it comes to a new task. So there's some really, really interesting opportunities there. And I think the simulation component to that's important because that allows you to do a lot of that work offline, which of course does not cost you any uptime in terms of your production. But I think there are opportunities for AI integration both at lower levels and higher levels of automation. At lower levels, we can really think about highly specialized machine learning models to do process adjustments and improvement. If we think about machining processes, all our low-level processes and how variations occur there in terms of our materials and our environmental conditions, and AI machine learning, I guess, has a really important role to play there. And at a slightly higher level, we can think about how AI can play a role in scheduling and routing optimization, as Jeff referred to, but also we can think about in the future how AI can predict fluctuations in demand, either through enterprise data or even external data. If we think about AI interpreting markets, interpreting how clients either client behavior or client responses or reviews has become a really interesting facet of AI development in the manufacturing context.
Okay, thank you, Carl. It all sounds great, but the next question says, what are the challenges in achieving this, and what are kind of some of the benefits you might gain? We've talked about a little bit about that, but this isn't easy, I feel sure. What do manufacturers need to do? Where do the challenges lie?
Yeah, so I think when it comes to AI and let's say maybe more specifically machine learning, especially where companies may want to really do highly specialized or custom model development, maybe in-house, it is something that has become more accessible to do. The thing is, you need a good digital or even cyber physical architecture to ensure that you've got big volumes of good data to obviously serve as foundation for training these models. There's some challenges related to moving beyond single standalone applications to scalable and customizable deployments of AI to serve, obviously, to be more flexible in terms of what we're talking about and in terms of their use cases. There's challenges related to safety and reliability. Can we trust these models to always, make the right predictions and the right adjustments? And so it's really an issue if we think about reality affecting AI. So when we give AI the levers to make physical changes, which I think is a significant challenge. Also challenges related to how AI is integrated with your human resources. So are we creating black boxes that reduce situational awareness and the risks that come with that? Do we take control out of the hands out of our technicians and our operators? And what does that mean for knowledge loss over a long period of time when we start to really rely on AI to make some of these key decisions? And I think there are also similar challenges still on a technical front for integrating AI with automation systems. So how do we build up the architectures to ensure that we can have appropriate information transfer feeding into AI and again coming out of AI and affecting the way that our automation system works? You want me to go into the benefits now as well, or are we coming back to that?
No, go through the benefits if you would, please. Briefly.
All right, just quickly. So, I mean, of course, we can have, really automatic regulation and improvement, which is, is obviously going to lead to, improved efficiencies. We've already spoken about the benefits in terms of flexibility, handling variation, handling changes, which of course, I don't think we have to motivate the value of that. Again, also in terms of we talk about variation, we're talking about better fault tolerance and disturbance handling, which gives us more availability and uptime. Of course, easy to motivate that. And I think it also, because we have the ability to predict it, would has benefits in terms of agility. So essentially the ability to make use of our flexibility, which I think is a really key aspect that I think AI can address.
Okay, thank you. I'm going to move on now because I'm interested to get to our final poll question here, and somehow this kind of thing is organized, who does what. And the question is, what approach does your organization take or plan to take to building or buying flexible automation? So while you answer the question, and again, you could answer more than one question, I think, but I'm not sure that would really work very well. Let me come back to Jeff to talk about this, build, buy, team up. How best can manufacturers mix in-house engineering expertise with global automation partners to get these flexible lines we talk about and assembly cells live in months rather than years? It's a lot to be doing.
Yeah, I would say, the approach that I've seen companies, like ours adopt is really, in-house automation tends to focus on developing and deploying common platforms that can be customized for specific applications. And so it's basically, faster speed, to deployment and implementation, because, you're able to leverage a common platform without having to start from zero on the development cycle each time you want to deploy one. So that's, helped us be able to, remove, as I mentioned previously, some of that low-skilled or non-skilled labor that we find just about, in every manufacturing site that we operate, perhaps even on every manufacturing line that we operate. And then, we tend to leverage external partners for, much more large-scale, full end-to-end automation solutions. That may have really high degrees of customization that don't as easily translate. And so, we find that there are third parties that, perhaps have somewhat of their own platform offering, but is far more complex in scale and, has the ability to be customized for a given application that we're trying to solve for. I would say, partnering often involves, the in-house teams really owning the requirements capture, and, defining the solution requirements, and sometimes there can be a division of what is actually developed, from hardware perspective, internal versus external. But in terms of roles and responsibilities, we find that in-house, there's an outsized focus on, maintaining uptime post, commissioning, as part of a key focus long term, whereas the external partners typically handle system engineering, initial deployment and commissioning, things of that nature. So we find ourselves doing both, but kind of dependent on the need set. But that kind of would be my experience. I'm sure Justin is far closer and might have some additional insights to share.
Okay, yes, please, Justin. What do you see out there?
Yeah, I agree 100% with what Jeff was saying. I think the hybrid model kind of sums up what was just talked about. Is we understand what we're good at. We understand what our strengths and design skill sets are. In different industries, we have thousands of engineers and close to 100, I'd say, automation specialty engineers globally that we can lean on and determine if we want to design something specific to a system or a customer request, or we lean on partners that have off-the-shelf equipment, off-the-shelf programming and hardware, and then we own the IP. So the hybrid model, I think, is probably one of our most strategic approaches when it comes to external customer requests. And then the internal design, obviously, I do want to highlight our expertise in that because we do, we look at sites and determine what projects and optimization opportunities there are. And if we can deploy something quickly and internally design it and buy all the parts and fabricate it and test it, we'll do that approach. And if it's a multi-million-dollar project that we're quoting multiple assembly lines on, I think it just comes down to ownership. Is like I said, we own things that we know we can control, and then we put ownership back on our suppliers to take some of that responsibility for things that they've developed over the course of decades, not years. So we lean on people that we know are true and driven in the industries, and then if there's something we specialize in, such as traceability, data storage, collection methods, that's where we kind of pinpoint our expertise.
Okay, thank you. Maybe see those poll results, please. And Jeff, perhaps you'd like to comment on these ones. Where are we? Here we go. Yeah. Is that what you might expect?
Yeah, and I think that it may seem somewhat obvious, right? That you want to have enough understanding and ability to have confidence in perhaps specifying for external partners automation solutions, right? And so the fundamentals are not developed any better than just doing it internally, and it drives a greater sense of ownership and accountability as well, versus say just entirely relying on outside third parties, right? Where you're kind of limited in terms of controlling your own destiny. But again, there typically is somewhat of a threshold that is a bit of a gray area perhaps. But in a lot of times it's time to market requirements. We could do this all ourselves if we wanted to, but with the limited resources we have, it would take far too long for us to be able to develop and deploy the solution. Could be cost implications, geographic implications as well. A lot of that drives kind of the decision versus build or buy.
Okay, thank you very much. I assume this will also evolve as time goes on, and there are more types of techniques and technologies as well that you can deploy. Thank you very much indeed, both of you. And let's take a break for some questions. I have some in from our audience now. And let me come first to you, Justin. This question asks, what should firms be looking for when selecting a partner for flexible automation?
What was the first part of that, Sarah?
Sure. What should firms be looking for when selecting a partner for flexible automation? What do they want?
I think to start with a plan. Developing a system is one thing, and proposing a plan that's feasible is another. But also having examples of processes and equipment that we've deployed globally, and being able to provide that as an upfront example, or at least as a justifiable reason to use us. We specialize in different types of robotics and processes. You might not always see it in one location of our global organization, and you'll see it in another. So we're trying to get towards having a standardized automation approach, and I think that's super critical. That if you work with a global organization, the way you deal with automation, it should be the same in Asia as it is in the United States or in Mexico. And I think having that consistency on what the expectation is, especially with global customers, is we get that sort of feedback, as it's super critical that the teams are familiar with who they're working with, the approach that they're given, and then also upfront cost.
Okay, fine. Thank you for that. Jeff, coming to you with this one. Many manufacturers are suffering significant cost pressures. How can they prove ROI and win budget for investment in flexible automation?
It's a good question. I think one that really plays in is consideration of the product life cycle as it relates to ROI. So if your product life cycle is one that's quite short, right, where it's not long before the next generation is released, then there are different considerations in terms of CapEx relative to ROI, volumes in demand variability, perhaps even forecasting error, things of that nature. It drives some interesting complexities. And then kind of back to what Justin mentioned, really having a mindset of designing with automation in mind, right? So that you can reduce the amount of retooling or reconfiguration that might be necessary for enabling an automated production solution for a next generation product or multiple generations of products over time. Really helps ensure that you're maximizing your ROI for a given automation solution, without having to kind of start over and limiting, perhaps the payback period that might be acceptable, and things of that nature.
Okay, thank you very much. And I'm going to come to you next, Carl. And this one says, how can we mitigate cybersecurity concerns when using AI and automation? The data the system would have about how to build our products, where defects are common, etc. These things are very sensitive. This is a big problem with AI. How would you answer that in this sort of situation?
Well, I think it's a really relevant question, and I think the first step would be to make sure that cybersecurity is considered from the start of these processes. Whenever there's a discussion about AI integration to take place, I think cybersecurity should be high on the priority list. And this is where I think the big challenge comes in, where the more secure applications, more secure integration of AI are likely the applications where these models run on premises, within enterprise boundaries. And that's also obviously the sort of scenario where you need probably the most in-house expertise to support something like that. And I think that's maybe what companies should consider. If this is a technology or an opportunity that they want to exploit, it is worth investing in the skills and the expertise in-house, or at least consulting or bringing that expertise in to understand what the risks are, and to understand what the options are in terms of mitigating that risk. So and I think just in terms of not just AI, I think data sharing in itself is still considered quite a risk. We've seen that in sort of failures of big projects looking to create shared data spaces, and this is also an interesting problem where, how does a company protect its IP? How does it protect its sensitive proprietary data? So really relevant question. Hopefully we'll come up with some good answers to that question in the near future.
Okay, thank you. And I've got one more for you, Jason, here directed directly to you. It says, Justin talked about design for automation. How can a development team do that if they're going to be outsourcing manufacturing and don't necessarily know what automation is likely to be used?
No, I think, yeah, that's a very relevant question. I think starting from basic principles, how would you pick something up with your hand and how does that impact you? I think understanding how it individually impacts somebody from a manual operator status, that's always given me a window in the creative design luxury to kind of think of things in advance. And, even if people aren't experts in design for automation, I think overall they understand in a manufacturing environment what works movement-wise, what environmental factors play a part in the current variables of quality. And that is enough information to get started on the outsourcing effort. I think collection of the correct information is super critical, because integration partners and robotic partners are willing to give iterations of design, sometimes at no cost, if you just work with them and give them ideas of what the current environment looks like, how the people are currently operating or functioning, and what the results are on the product itself. I think putting those pieces together up front really allow for suppliers and robotics partners, if they're not able to come into the building and see things or get a video for security or privacy reasons. Having that sort of dialogue up front at least gets the window or the discussion started. And I think that's a bare minimum that teams internally and externally can work with companies on, because we shouldn't just, take a packet of engineering drawings and pass it over to our suppliers. We have to do some sort of interpretation. There has to be some sort of filter of the most critical factors that are important, because we're the owner for the customer, and they're kind of just the third party that's managing our requests. So we want to make sure we're giving them everything up front that they need.
Okay, thank you. I'm afraid that's all the time we have for audience questions now. So let's get back to my agenda and coming back to you, Justin. Please, would you talk briefly through an example of flexible automation in practice?
Sure, I'll try not to get too in detail on certain steps, but one of our current products that we're working through on a flexible automation solution is for thermostat packages. We have a few different sizes of a top cover and a bottom cover thermoformed mold. The parts are organized into trays, so we pre-sort the materials up front before it gets into our automation work cells. The parts are identified with our camera systems before they enter into the robotic handling for assembly. The camera system, it inspects parts as they're coming out of the part feeders. If the parts are bad, the defective parts are actually picked up and rejected out of the system so that it cannot be performed or any operations can't be executed on the next step. Once the plastic housings move from the loading side of the conveyor station, they're moved into the positioning of our circuit board. The circuit board gets directly placed into the bottom housing. An inspection is performed to verify accuracy of the placement. If any of the components are damaged, we generally will pinpoint specific CTQs in the camera system or parameters that it needs to look for. If everything is good, the top cover housing gets inserted into the assembly. So we have pretty much a top cover, PCBA, and then a bottom cover that gets assembled. Once it's assembled into that step, we have another camera step that verifies all the alignment features, through hole components, anything like that. Those were previously checked at SMT. Once everything is confirmed for alignment, we have different size screws that are used on multiple SKUs. So the screw feeder identifies what the serial identifier is in the work order through our traceability system. It auto selects the screw sizes. It auto selects the program positional points and then secures the screws in place. Once the screws are secured, the unit is picked up, inspected again, and then moved into the packaging line. The packaging line, before it gets placed into the tray, the thermoform tray, we do a batch up. So there's anywhere from 50 to 75 units in a box, and that can vary depending on the product number and then the product size. So we're, as Jeff touched on before in the packaging configuration flexibility, we're multi-packing different quantities inside of the boxes. We are packing or labeling it with different labels depending on the product configuration. And then the test results. If any of the test results from the SMT line are failed or have any issues for rework, we will also store that in our final traceability recording data point before it goes in the box. So from end to end, we have automatic part feeding, automatic part detection and inspection. We have automatic defect rejection steps, as well as automatic packaging. So overall, really when it comes into the warehouse, that's your main handling point of manual labor. And then as far as when it gets to the line, the camera systems basically determine what the workflow is and the tooling and the jigging that's going to be modified. So we have self-locating features on pretty much any jigging and fixturing inside the system. So if the part changes in shape or size, the fixtures auto adjust as well, depending on the camera reading. So the flexibility there, it's not the highest volume runner product that we have, but as well, as far as the customer satisfaction side, we've gotten a lot of good feedback, and we're actually in the process of upstaffing the line so we can basically incorporate more automation cells for that customer.
Okay, thank you. Conscious of time, I'm going to come to our final item of today. And I'd like to ask all our speakers to offer some advice to practitioners planning, implementing, or using flexible automation. So Justin, a few words from you if you'd like to start here.
Yeah, the two biggest things I think we touched on independently were design with scalability in mind. Obviously, you don't want to start too large. I think starting small and working the design concept into a larger concept is definitely the easiest approach. Because it takes a little bit shorter time to design each process, and you can test and you can test independent cells without having everything connected, and then you can go on and test it later on. So I think that scalability factor shouldn't be limiting when it comes to starting small and working your way to a larger project. And then the most important thing I think Carl touched on was the secure data layering. Obviously, having a filter for AI and machine learning, it should be used as a tool and not as an experiment. And I generalize that as a statement because I think us understanding it, for the one example I'll give is if I put anything into an input chatbot or an AI tool, as long as I'm providing that sort of insight to the company or from a cybersecurity perspective, knowing what information I'm inputting into those systems, and then also the filter of how that information is interpreted, the company should be more familiar with allowing, automated teams and automated designers to use these tools for feedback and any sort of improvements in the design. And really, it just comes to how do we communicate that more openly without limiting the sites and limiting design through security layers. We should be able to give sites more freedom and more luxury, and then do the review as we're working through each of these inputs. So the AI machine learning secure layer approach, I think, is super critical going forward, and then the scalable enterprising.
Lovely. Jeff, some advice from you, please.
Yeah, I guess last minute advice. I wanted to comment really on one of the questions that was asked earlier about how do we, decide how we design our product for automation if we don't know who our partner is. My suggestion is solicit input from the potential partners that you're looking for, and ask them if you were to come back to us with ideas on how we should design this product with automation in mind, how would you do it? And then aggregate that feedback, look for the common themes and trends, and you pretty well bet that that's a sound idea to consider adoption of, regardless of who you pick ultimately, because that's the input that you should expect from an automation partner or just a manufacturer that has automation solution capability.
Okay, thank you very much. And some last words from you, please, Carl.
Right. So just quickly. So first piece of advice would be to understand that flexibility in automation systems can only be fully exploited within agile systems. So that means is you can spend a lot of money buying state-of-the-art robots and AGVs and everything that gives you the capacity to be flexible. But if your business model all the way down to your scheduling systems and your supplier network, if that's not agile, you will never be able to fully utilize the flexibility that you have in your automation system. Second piece of advice is that it's worth companies taking the time to do a good strategic design of their digital or cyber physical architecture, because at the end of the day, that is going to be something that they can continue to leverage and guide them strategically going forward. And then finally, which is I guess slightly against the grain here when we've been talking about automation, I think it's really important to continue to train and upskill your personnel so that you can have good in-house expertise to guide your decisions, even when those decisions lead to more automation.
Okay, thank you very much indeed, Carl, and thank you to all our speakers for sharing their experience and expertise with us. Thank you too to Benchmark for sponsoring today's webinar. Before we close, just a quick reminder of some of the Manufacturing Today on-demand webinars you can access on the website. Engineering the Future with Human and AI-Driven Analytics, and then the Next Gen Factory around mastering IT and OT convergence. That said, that's it for today. So thank you again to Jeff, Justin, and Carl, and thank you to all of you who've taken part in the webinar. Please complete our feedback form, as we're always keen to hear your views and improve our products. Meantime, thanks again and goodbye.
Thank you, everyone.